Today we are going to discuss another very easy concept in Algebra 1. So last class we talked about graphing on a coordinate plane, and we talked about finding whether a relation is a function or not a function. Very easy. So along those lines, we are still in the same world, and this time we are talking about domain and range. This is one of the easiest, but one of the most important sections in Algebra 1. So what you need to know is that the word domain means X. So every single time you see the word domain, I need for you to write the letter X. Range is the letter Y. Very, very easy. So from a table, my X's are my domain and my Y's are my range. Very, very easy. So when we write the domain of a table, the way we write it is with this little squiggly line. It's called set notation. And then we're going to list our numbers. We list them from smallest to biggest. So the smallest number in my X numbers is a -5. Then there is a -2, then a 3, and then a 9. And then we'll close it with another little squiggly line. So if that is my domain, then my range has to be the Y-let numbers. So here is Y. So my range are my set of Y values. So I just take these numbers and list them. So with these here, again, squiggly line. So my range, I like to list smallest to biggest. That's the best way to put it. So the smallest number is a 2. Then I have a 3, a 5, and a 9. Very easy. So again, domain is the X's and range is the Y's. So we're going to do the same thing with the next example. But before that, we need to answer this question. Is this a function or is it not a function? So in the last worksheet, we talked about function versus not functions. So what we do is we look at our X values. So in these X values, I check to see if anything repeats. If there's an X value that comes back, then it is not a function. So if we look at these X's, they're all different. My girls are faithful. This is a function. So we're going to do the exact same thing with number 2. So again, domain is my X's. Domain is almost always already written in order for you. So domain's really easy. So the domain of this table, I have a 0, 1, 2, and 3. Those are my X's, so that is domain. Range is my Y values. So my range is the numbers 4, 5, 6, and 7. The hardest part about this page is being able to draw these little squiggly lines. Everything else is so easy. Domain is the list of your X's. Range is the list of my Y's. This is a 5. It's just very ugly. There we go. Okay, function or not a function. So when we are looking at function or not a function of number 2, again, we are checking our X's. So when I look at these, my X's do not repeat. They're all different, so we are good. This is a function. Very, very easy. So now we're going to do the same thing with the next set of examples. Okay, numbers 3 and number 4. So in 3 and 4, this is called a mapping diagram. It's so easy. It works the same as anything else. X comes first, Y comes second. So again, domain is the list of X's. Here are my X values. So my domain is just a list of those X's. It's a squiggly line. And then my answer is 1, 4, -8, and 3. But to be the most correct, it's best to write them in order from the smallest number, which is -8, to the biggest number, 1, 3, 4. Close the squiggly line. So domain is the list of x's. All of the x numbers in here made it into my domain, which is right here. So if domain is x, then range is y. So my range are my y values. Again, I start with a squiggly line, and then I list my y's. They're already in order, so it's just a 5, 6, 7, and 8. There. So in this one, we have our domain and we have our range. So now the next question is asking whether this is a function or not a function. So just like in the earlier questions, functions mean we look at our x's. If we look at these x values, all of these are different. So this here, ooh, they are not different. So if we look at these x's, we have this number. Its name is 4. It's going to the 5, and then it's also going to the 6. So this here is not a function because the x value of 4 went to this number, and it also went to this number here. So in number 3, this is not a function. An x value repeated itself, making this not a function. So now one more, just like that. Domain is x, x's come first. Range is y, y's come second. So again, super easy. Start with our domain. That's our x's. Squiggly line. List our x's in order. 1, 2, 3, and 4. Very, very easy. Range is y's. So my range is my y values. There's only 3 of them. That's fine. It's a 5, a 6, and a 7. Function or not a function? We check our x's. So to check if this is a function, each of these lines only have, each of these numbers just have one line coming off of them. So we're good. This here is also a function. So easy. So easy. So now we're moving down to ordered pairs. In an ordered pair, we do the same thing. Our x's come first. X's are the domain. Y's come second. So y's are my range. So for the domain of my first set of ordered pairs, again, little squiggly line. So my domain is the x's. So I'm going to circle them so that way we can see exactly what we have here. So there are all of my x values. So easy. I take those numbers. They're already smallest to biggest. How nice. So it's -3, -1, 0, 2, and 4. Then I have my range values, which is going to be my y's. So to get my range, I have -7, -3, -1, 3, and 7. So in this here, my range, always the y values. Again, they're already in order, so nice. So it's a -7, -3, -1, 3, and 7. So easy. Domain is x, and range is y. Last question, we're checking function or not a function. So in this one here, all of these x values are different numbers, so we're good. It's faithful. This is a function. Same with number 6. We're going to start with domain, exactly what we just did. We look at our x's, and we list them from smallest to greatest. So my smallest is a -5, -4, 0, 1, and 2. All of the x values in order from smallest to biggest. My range is my y's, so easy. So my y values are -4, 2. There's another 2 here. You don't have to write it again. I already know that there's a 2. in my range, so you don't need to write it a second time. 3 and 4. Very, very, very easy. So again, domain and range are done, but now I'm checking for function or not a function. We check our x's. They came first. None of these numbers repeated. None of these girls came back with someone new. So it is faithful. This is a function. All of my x's were good. This is a function. So in the last type of domain and range on this page, the bottom is very easy. We are getting the domain and range from a graph. But in this type of graph, I want you to write the word discrete. What discrete means is that my points are ordered pairs that are not connected to a line. There's no line going through them, and that's on purpose. We don't want a line that connects them. Next week, we'll talk a little bit more about how this works in real life when we would have graphs that don't have lines. So if you ever see a graph of dots, it means that we call it a discrete graph. So you can remember the D in discrete is like the D in dots. So if we have ordered pairs or dots, that means that we have a discrete graph. So the way that we find the domain and range from a discrete graph is very, very easy. So what we do is the easiest way is we're just going to make a table of these ordered pairs. Then we're going to find the domain and range just like we did for the tables above. So if I look at my first ordered pair, it's right here. That ordered pair has an x value of 1 and a y value of 3. So that's the ordered pair 1, 3. First one is done. Next, this ordered pair has an x value of 2 and a y value of 1. So that's the ordered pair 2, 1. Done. Next one has an x value of 3, a y value of -1. Done. Next, write 4 up 2. Next, write 5. It does not move up or down, so that's the ordered pair 5, 0. Went to the right 5, did not change its y value. And then finally, we have this ordered pair 6, and it goes up to 6. So write 6, up 6. So I took my ordered pairs, my dots from this graph, this discrete graph, and I wrote each of them down on my table. So now I can make a list of the x's. Remember, domain is x. It is 1, 2, 3, 4, 5, and 6. And then I make a list of my ranges. Range is y. In this one, it's best to list them from the smallest number to the biggest number. If you can at least identify which one is range, then you are in the right track. So in this one here, my smallest y value is a -1. Then I have a 0, a 1, a 2, a 3, and a 6. I took all of these y values and I put them in order from smallest to greatest. So now, to check to see if something is a function or not a function, I check my x's. If we look at this table, make this go good enough. So if we look at this table, my x's are all different. All of these x values are different. They did not repeat, so we're good. This is a function. So now I want for you to take a minute and try to give me the domain and range of this next graph, discrete graph of these ordered pairs. I'll start you off. This is my first one. It's good to go from left to right. Makes it a little bit easier to not miss any points. So the first one is a -2, 4. So So now go ahead and write your other ordered pairs on your table, and then write the x's as your domain. Domain is always x, range is always y. Very, very easy. Once you are done with number 8, go ahead and flip it to the back and try the domain, range, and write whether it is a function or not a function for each of those. Very easy. So the next thing that we are going to do is switch from graphing those things called discrete graphs. So this piece is not in your notes, but I just want you to pay attention to this piece here so you understand the difference between these two types of graphs. So we said that discrete graphs are made of a bunch of dots. So easy. To get their domain and range, we made a table and we listed the x's and then we listed the y's. So easy. Domain is x, range is y. But the next type of graph we're going to do is called a continuous graph. Again, you don't have to write this down. This just allows us to understand what we're about to do. So in a continuous graph, what happens is we have two dots, at least two, sometimes more. But then we have a line that connects them. This is called continuous because we have a line that continues from one point to the next. So if I asked you to find the domain of this graph, you are not going to make a table of every single x value between this point and this point, because this is a point, 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 this is a point. Every single spot on that line is considered a point. Well, then this here is also a point, this here is a point, this is a point, this is a point, this is a point. So your domain would look like -4, -3.9, -3.8, -3.7. Every single number between here all the way to here would be a really long list to write, because now it's not just individual points like it was for discrete. It is a ton of points from start to finish. So mathematicians made an easier way to write down the domain when we have a line that continues from one point to the other. So in your packet, let's go ahead and find this page here. So this is how we find the domain from a continuous graph. Remember, continuous means it continues from point to point. That's what continuous is. So if we look at our notes, very easy. D stands for domain. A little smaller. Good enough. Okay, so D stands for domain. So in your notes, I need you to write D is for domain. When we're finding domain, domain is the x. So we go from left to right. So to get the domain of a continuous graph, what we're going to do is we are going to highlight the furthest left edge, and then we're going to highlight the furthest right edge. So let's look at that in our first example. So if domain is x, this is the furthest left x on my first example. And then this is my furthest right edge. My domain is x's. This is how far left it goes. This is how far right it goes. Then it asks which x-axis numbers does that line cut through? We're going to write it just like it says here in step 3. So all of my x's are between, that means between in math, all of my x's live between my two borders. They live between these two edges. So the furthest left x value is right here. 1, 2, 3, 4, 5, 6, 7. -7. My furthest right edge is 0, 1, 2, 3, 4, 5. +5. So my x's, my domain, live between x is -7 all the way to x is +5. However, we need to be very careful with these symbols. What happens is if there is a closed circle on the left edge, it means I have to close off the left inequality here. What that means is this line includes the x value of -7. On the right edge, it's an open circle. That means we leave our inequality open. Because it's not colored in, this line does not include the number +5. Seems difficult, but once we do it a few times, it will be very, very easy. So let's try the exact same thing. So it says, for domain, we highlight the left edge, and then we highlight the right edge. When I write domain, I always put an x is between two numbers. The furthest left number is right here. That's the number -3. The furthest right number is right here. That's the number 1, 2, 3, 4. My x's live between -3 and +4. This left edge is an open circle, so I keep this symbol open. Right edge, open circle, keep that symbol open. So domain is a left to right. Left side of the graph, right side of the graph. We looked at which x-axis number was on this left edge. Which x-axis number is on the right edge. So now we're going to try a few together, and then you can try a few on your own. So try some. Domain is left to right. Very easy. So domain, here's my left edge. Here's my right edge. Domain is x, smushed between two numbers. So my x's live between, the left side is 1, 2, 3, 4. It's negative to the left of the origin, so -4. Domain on the other side, 1, 2. My x's live between -4 and +2. However, this is a closed circle, which means we need to close off my inequality symbol. Also, closed circle, so I also need to close off this inequality. So I'm going to do the exact same thing with number 2. Domain is left to right. Domain is x. X's are between two endpoints. This endpoint is the number 1, 2, 3, 4. So I write that as -4. The right endpoint is 1, 2, 3, 4, 5. So that's the number +5. The left side is open, keep your sign open. Right side is open, keep your sign open. Same thing, number 3. Again, I find the left edge, I find the right edge. Domain is x, and they're smushed in between. I don't care about this point up here. I don't care about any of this stuff in between. All I need is the furthest left to the furthest right. The furthest left side right here is a +2. The furthest right side is a 1, 2, 3, 4, 5, 6, 7. Left edge is a closed circle, so I need to close off my symbol. Right edge, closed circle, close off my symbol. Easy. Domain is left to right. Same thing, number 4. Domain is my left side to my right side. Domain is x. My x values are smushed between 2 numbers. The furthest number on the left is 1, 2, 3, 4, 5, 6. It's a negative 6. Domain on the right, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Domain on my right is a positive 6. On the left side is a closed circle, so I need to close off my symbol. Right side, also closed circle, so this is going to be an inequality with a line underneath it. Looks like that. Closed inequality. Last but not least, domain, left to right. X's are between. My furthest left x is 1, 2, 3, 4, negative 4. Furthest right, 1, 2, 3, 4, positive 4. This is a solid line, so I'm going to solid line underneath my symbol. Solid line, so I put a solid line here. So go ahead and flip over to the back and try domain from a continuous graph on the back on your own. All right, last but not least, so go ahead and flip to our final page. So again, we did domain is x's, range is y's. So we need to learn how to find the range from a continuous graph as well. Very easy. So range is my y values. Always, always, always. Range is y. Well, on the y-axis, numbers go up and down. So we're going to start at the bottom and go to the top. So this one here, range is bottom to top. So what we're going to do this time is we are going to highlight the bottom edge. Has to cut through the y-axis. Range is y. There we go. Cut through the y. That is the lowest y value on my graph. And then we have the top. That is the highest y value on the graph. To be silly, I always used to say that range is like Drake. So Drake starts at the bottom, and now he's here at the top. So now in this one, we had range, we highlight bottom to top. Just like before, but this time we're going to say which y-axis numbers cut through that line. And then again, we write it the same like before, but this time we use a y because range is the letter Y. So to write the range of this continuous graph, range is always y. So I'm going to start by writing the letter y. So these y values are between 2 numbers. They're between 2 end points. One was down here, and the other highest y value is right here. So y's are greater than some number. They're above some number. And y's are less than some other number. They live below your other number. So when we write this, we begin by writing the bottom number and then the top number. So the lowest y value is 1, 2, 3, negative 3. The highest y value is a positive 1. So in this graph, every y value that is graphed on this line live between the y value of negative 3 all the way up to a y value of positive 1. So we'll do another one just like that. Range is y. Hold on. Before I do that, I need to check my sign. So in this one, the bottom y value is a closed circle. So I need an inequality that would include this ordered pair. The top y value is an open circle, so I'm going to keep this one here open. So now I have range again. Range is y. My y value goes from the bottom to the top. So the y values start at the bottom, and now we're here. So my y values are between. They're greater than some number, and they're less than some other number here. So the y values live between. This y value right here is a 0. This value up here is a positive 1, 2, 3, 4, 5. The bottom is a closed circle, so that gets a closed line. The top is open circle, so that gets an open symbol. So my range is my y's. They live between the y value of 0 all the way up to the y value of 5. So let's try a couple on your own. Let's try a couple together, and then you'll try a few on your own. Okay, starting with number 1. Remember, range is y, so I'm going to start by writing a y. My y value is between, my y values live between two numbers. The lowest y-axis number is right here. So we start at the bottom, and now we're here. The bottom y value is the number 1, 2, so negative 2. The top is 1, 2, 3, 4, positive 4. The bottom is a closed circle, so I close this off. The top, closed circle, so I close this off. So to be silly, the way that I always used to remember it is that range is like Drake. So Drake's name has an R-A, and it ends with an E. Range has an R-A, and it ends with an E. So in this graph, range is Y. What does Drake do? Drake starts at the bottom, and then he goes all the way to the top, not the middle. I want the highest point on this graph. Started at the bottom, and now we're here at the top. So my range, or my y's, they live between two numbers. My lowest y value is a negative 2. My highest y value is 1, 2, 3, 4, 5. My bottom y value is a solid line, so I need a solid line. Top is an open circle, so I keep that open. So go ahead and try your range, bottom to top, bottom to top, bottom to top. For the rest of this page, then flip over to the back and try the range from our continuous graphs on the back.